Good morning all. Now we will discuss about construction of a PNP transistor. Okay, now see here, PNP transistor is formed. Okay, here n-type material is sandwiched between two p-type materials, then only PNP transistor is formed. Okay, here this transistor is having three terminals, right? Emitter, base, collector, right? Here input junction or emitter base junction is in forward bias and collector base junction should be in reverse bias. That is, see here, p-type material is connected to positive terminal of the battery and n-type material is connected to negative terminal of the battery. Then emitter base junction is in forward bias, right? Here p-type material is connected to negative terminal of the battery and n-type material is connected to positive terminal of the battery. Then collector base junction is in reverse bias, right? From the figure, emitter base junction is forward biased and collector base junction is reverse biased, right? When emitter base junction is in forward bias, here, okay, in p-type material, holes are the majority charge carriers, right? Okay, that means these charged particles which is connected to supply positive, right? Positive charge and positive charge repel each other, hence holes will start move from p side to n side. Because of this rearrangement, it will constitute a current of emitter current. Okay, see here, when emitter base junction is forward bias, holes in the p-type cross the junction and constitute emitter current. Okay, now see here, as the holes will move from p side to n side and recombine with the free electrons available in the n side material, okay, this will constitute a base current IB. Okay, after that, already we know that this base is lightly doped. Okay, base is lightly doped, hence only few electrons will recombine with the available free electrons in the n-type material. Remaining 95% of holes will recombine with the free electrons available in the p-type material. This will constitute a current of collector current IC. Okay, that means in PNP transistor also there are three currents will be present: emitter current, base current and collector current. Okay, then the total current will be, emitter current is the sum of base current and collector current. Okay, the emitter current is the sum of base current and collector current. Okay, next topic is transistor configurations. Okay, already we know that transistor is having three terminals: emitter, base, collector. Okay, now see here, based upon the types of configuration, that means based upon the type of arrangement, transistors are arranged in three ways. One is common base configuration, another one is common emitter configuration, another one is common collector configuration. That means based upon the type of connection, there are three types of configurations are there. Okay, first one is common base configuration, common emitter configuration, common collector configuration. Okay, here common is nothing but, okay, the transistor lead, that means the transistor terminal which is common for both input and output is known as common. Okay, if we first we will discuss about common base configuration. Okay, here I am considering a PNP transistor. Okay, here it is a PNP transistor. Current will flow from emitter to base, right? That is P to N. Okay, now see here, this is input loop, this is output loop. Okay, here it is input loop and here it is output loop, right? Here VEE and VCC are the biasing voltages. Okay, here VBE, base, the voltage between base and emitter terminal is nothing but VBE is the base emitter voltage. ORR, input voltage. Okay, the voltage between base and collector terminals are nothing but base collector voltage or output voltage. Okay, here IE is the input current, ORR emitter current, IC is the output current, ORR collector current. Okay, this total is input side, here this total is output side. Okay, now see here, for this input, base is common for both input and output, hence the name as this transistor is common base configuration. Okay, this base terminal is common for both input as well as output, hence the name is common base configuration. Okay, next, from this circuit diagram, we need to calculate current amplification factor for each and every factor, right? That is current amplification factor. In case of common base configuration, current amplification factor is denoted by alpha Okay, that is equals to change in output current divided by change in input current. That means current amplification factor is defined as the ratio of change in output current to the change in input current. Okay, now see here output current is IC, input current is IE. Okay, that means current amplification factor alpha is equals to delta will be represented by change, that is delta IC by delta IE, change in output current divided by change in change in emitter current, that is alpha is equals to IC by IE. Okay, from this equation IC is equals to alpha into IE. This will give the relation between output current and input current, right? IC is equals to alpha into IE. This is the assume this is as a equation 1, but the total output current is given by total output collector current is given by IC is equals to current due to majority charge carriers, that is nothing but this one, current due to majority charge carriers. This is current due to majority charge carriers plus current due to minority charge carriers, that is minority current of ICBO. Okay, ICBO indicates here CBO, right? CB indicates common base configuration, O indicates minority charge carriers current. Okay, then total output current IC is equals to IC plus minority charge carriers current ICBO. Okay, that is IC is equals to, already we know that IC is equals to alpha into IE. Substitute here alpha, IC is equals to alpha into IE plus ICBO. Okay, then IC is equals to, already we know that from the construction of a transistor, IE is equals to IB plus IC. Substitute here, you will get IC is equals to alpha into IB plus IC plus minority charge carriers current is ICBO. Okay, then total collector current or output current is equals to alpha into IB plus alpha into IC plus ICBO. Okay, if I simplify this equation, I can take alpha into IC on LHS side. Then if I take IC as common, you will get IC into 1 minus alpha is equals to alpha into IB plus ICBO. Then collector current IC is equals to alpha by 1 minus alpha into IB plus 1 by 1 minus alpha into ICBO. This is the output current equation if we consider minority charge carriers also. Okay, if the output current for only majority charge carriers, output current IC is equals to alpha into IE. Okay, that is about common base configuration. Okay, next class we will discuss about input and output characteristics of common base configuration. Okay, thank you.